Alright, this is my presentation on infinity. My name is Jackson Jason. Go ahead and move on to the next slide. Here we're learning about the symbol for infinity. It was first used in 1655 by the English mathematician John Wallis in his book Dissectionibus Conicis. Yeah, don't speak French. It was also used by George Cantor, and he used it to make groundbreaking advances in the years 1874 and then 1884. I don't know if he took a 10-year break or it just took him that long to make his next advance, but it took him a decade. And over here we have the infinity symbol. This actually is the symbol for, I believe, the autism spectrum, if it is also rainbow. So, fun fact there. Okay, what is infinity? To be infinite is to be without an end. Infinity in mathematics refers to a number so large that it cannot be perceived or quantified. It is not something that can be proven to exist. If you think about it, if you had an infinite number of things, no, you don't. Because if you have an infinite number of things, you could have more. So, is it real? There's no really way to say yes or no. It's more of an idea that you base mathematics upon. Here are some concepts of infinity in practice. Most often you'll hear the word infinity used to mean a lot. You go to a restaurant and you say, do you got free refills? Can I just get one refill or two? And waitress says, you can have infinite. Well, obviously, she doesn't really mean infinite, because there's not enough soda on the planet to have infinite refills, because there isn't infinite soda in the universe. So, there is a limit to things. It is usually used as an exaggeration. As a student, you're most likely to see infinity on graphs. But we'll talk more about that later. I have another slide prepared for that. And then you'll hear it in regards to the universe. Outside of mathematics, the universe and possibilities are where the literal use of infinity are used the most. So this means that you can watch these documentaries about space, and they're very interesting whether you understand it or not, but they will repeat to you that space is theoretically infinite. And that's not really something you can grasp when you hear it, but they will repeat it. And you also hear about an infinite multiverse, infinite dimensions, infinite possibilities. And that's where you really have to distinguish between infinity as it is and infinity as it is sometimes used non-literally. Because in infinite, there's endless possibilities, literal endless. And so if you watch, I know, a few Marvel movies, they have what seems to be a non-literal amount of infinite amount of issues, but they don't seem to realize that with these multiversal issues, they have infinite solutions, a literal infinite amount of solutions. Just to ask for help from a universe where they've got it. Axes, arrays, and functions. This is the most common form of infinity that you will be seeing probably your whole life. You definitely saw it in high school. I mean, you're in college now, hopefully. So you definitely saw this in high school math. You know, the axes is the x-axis is the horizontal axis, horizontal being flat like a plate, and the y-axis is the up and down axis. Both of these on a graph usually end, at least on one side, with arrows. These arrows lead you to believe that these lines are arrays. Arrays meaning that they continue on, presumably, infinitely. You will also use infinity and negative infinity when describing functions. Also something you probably would have done in high school. You know, the domain of the function is the how far the function reaches from the lowest x value to the highest x value, so from the farthest to the left to the furthest to the right. For this graph specifically, if we assumed that both ends ended with an arrow, it would continue on from negative infinity to positive infinity. And the same could be said for the range, which would be how far the function goes from how far down it goes to how far up it goes on the y-axis. Cardinality. So this is a concept that has to do with infinity. It does not have to do with this cute little bird over here sitting on a swing. Also it doesn't have to do with this guy, the potential new pope. RIP, but has nothing to do with the Catholics. It just has to do with sets of numbers. So I've provided two examples here. For every letter in the alphabet, there are 5 children with a name starting with that letter. So in this example, the cardinal, or the number of sets, would not be 5 children. It is 26, because there are 26 groups of children, each with 5 in them. I could increase the number of children in the groups, but that wouldn't make the difference. The class of children divides themselves into groups of 3. We do not know how many cardinal sets are in this group, because we don't know how many total children were in the class, so we don't know how many groups we ended up with. The types of infinity: countable, uncountable, cardinal, and ordinal. Countable is all the natural numbers, meaning 1 to infinity. but it does not include, I believe it doesn't include irrational numbers. I'm not too sure about that. The uncountable is all real numbers. So that includes even the tiniest little numbers in between. Cardinal numbers, which we just described what cardinal is. So if you had infinite groupings of numbers, doesn't matter. And then ordinal, first, second, third, 5/billionth. Our summary is the biggest or smallest, or it is the biggest big or the smallest small. Does it exist? Yes and no. Do you have to know what it means? Meh. Infinity plus 1 still equals infinity. You can't really get bigger than that. That is the end of my presentation. Thank you.